Hello everyone. Today I am going to discuss the chapter Atomic Nucleus. In atomic nucleus, we studied radioactivity. What is radioactivity? At first, in 1896, French physicist Henri Becquerel observed some radiation from potassium uranyl acetate. These rays affect photographic plates. In 1898, Pierre Curie and Madame Curie named this phenomena of emitting radiations as radioactivity. Definition of radioactivity: the spontaneous disintegration of certain atomic nuclei of higher atomic mass accompanied by the emission of radiation of alpha, beta, gamma particle or rays is called radioactivity. The radiation emitted three types of rays, as for example alpha rays, beta rays and gamma rays. Later will known that alpha is not ray, alpha is particle and beta is particle. What is radioactive elements? The naturally occurring elements with higher atomic mass which spontaneous and continuously emit radioactive rays are called natural radioactive elements. After that, cause of radioactivity. There are several causes of radioactivity. One of the most important causes is the N by P ratio. When the neutron-proton ratio is greater than 1.5, then the elements shows natural radioactivity. Now we discuss about the characteristics of radioactivity. There are so many characteristics of radioactivity, and these are: number one, radioactive rays emit spontaneously and ceaselessly from a radioactive element. Number two, no effect does occur in the emission of radioactive rays even in the application of heat, pressure, light, electric field or magnetic field on the radioactive substance. Number three, if radioactive elements undergo chemical change and form other compounds, there is no change in their radioactive nature. Number four, radioactivity is a nuclear phenomena. Afterward, I discuss about this point. Number five, as a result of emission of radioactive rays, the structure of nucleus changes. That is, the number of proton and neutron in the nucleus changes. As a result, a new element is formed. Number six, the elements having atomic mass more than 206 are natural radioactive elements. And the last point is, in radioactivity, there are three types of rays are emitted. They are alpha, beta and gamma rays. Now we discuss about the various properties and compare these properties by this chart. So, comparative study of the properties of alpha, beta, gamma rays. We discuss about five properties of alpha particle, beta particle and gamma rays. Number one is nature, number two is charge, number three is mass, number four is penetrating power, and the last one is ionization power. First, we discuss about the nature. What is the nature of alpha particle? Alpha particles may be considered as a helium atom carrying 2 units of positive charge, and its formula is 4He2 positive 2. That is, 4 is the mass number and 2 is the atomic number, and there is 2 positively charged. What is beta particle? Beta particles may be considered as the stream of electron, that is E0-1, that is negatively charged particle. And what is gamma rays? Gamma rays is the electromagnetic radiation of very short wavelength. So alpha is particles, positively charged particles, and beta is negatively charged particles. So now we discuss about the charge of these particles. The charge of alpha particles is equal to the charge of 2 proton, and the value is 3.2 into 10 to the power minus 19 coulomb. The charge of beta particle are equal to the charge of an electron, and the value is minus 1.6 into 10 to the power minus 19 coulomb. And the charge of gamma rays is 0, as because it is a electromagnetic radiation. Now mass. The mass of alpha particle is 6.69 into 10 to the power minus 27 kg. The mass of beta particle is 9.11 into 10 to the power minus 31 kg. And as because of electromagnetic radiation, gamma rays have no mass, so the mass is 0. Now we discuss about the penetrating power. The penetrating power of alpha particle is least among these 3 particles and rays. It penetrates through 0.01 millimeter thick aluminum foil. The penetrating power of beta particles is greater than alpha particle but less than gamma rays. So the penetrating power of gamma rays is greatest among these 3 particles. Penetration through 100 centimeter thick aluminum foil. And the last one, the ionization power of gases. Alpha particles have high ionization power compared to that of beta and gamma. Beta particles have low ionization power and about 1/100th of that of alpha particles, and gamma rays, as because of its electromagnetic property, the ionization power is very poor and the power is about 1/10,000th of that of alpha particles. Earlier we discussed about the nuclear phenomena of radioactivity in the characteristic property of number 4. Now we discuss about this nuclear phenomena. Actually, emission of an alpha particle produce a new nucleus of an atom with atomic number less by 2 unit and mass number less by 4 unit than the original atomic nucleus. On the other hand, emission of a beta particle, the atomic number is increased by 1 unit than that of original nucleus. There is no change of mass number. Due to the change of atomic number, new elements are formed. So radioactivity is a nuclear phenomena. Now we discuss about emission of radioactive rays and formation of new elements. At first we discuss about the loss of alpha particles. When a radioactive element emits an alpha particle, the daughter element formed has an atomic number which is 2 less than the parent element and a mass number which is 4 less than the parent element. As for example, let X is a radioactive element whose M is the mass number and Z is the atomic number. When it emits an alpha particle, that is a helium double positive ion, it becomes Y, whose mass number is M minus 4 and atomic number is Z minus 2. As for example, uranium is a radioactive element whose mass number is 238 and atomic number is 92. When it emits an alpha particle, it produces thorium whose mass number is 234, which is 4 less than that of uranium, and atomic number is 90, which is 2 less than that of uranium 92. Number 2, loss of beta particles. When a radioactive element emits a beta particle, the daughter element formed has an atomic number which is 1 greater than that of parent element. However, the mass number remains the same. Let again X is a radioactive element whose mass number is m and atomic number is z. When it emits a beta particle, that is an electron, 0e minus 1, it produces another new element y whose mass number is same m, but the atomic number is z plus 1, which is 1 greater than that of the parent element. As for example, thorium, thorium, the mass number is 234 and atomic number is 90. When it emits a beta particle, it becomes palladium, or it produces palladium whose atomic number is 91, is 1 greater than that of the parent element, that thorium, but its atomic mass number remains same. Now the last point, loss of gamma rays. The daughter element formed after the emission of an alpha particle and beta particle are in a excited state of energy which is released in the form of gamma rays. So the emission of gamma rays does not result in the formation of a new element. We discuss about this loss of gamma rays by this example. Let cobalt 60 its mass number and 27 its atomic number. When it emits a beta particle, it becomes nickel excited state and the mass number is 60 and atomic number is 28. This excited state release the extra energy in the form of gamma rays, and this excited nickel become the normal nickel 60, 28 in the ground state. Now we discuss about the unit of radioactivity. There are several units of radioactivity. Among these, number 1 is becquerel, number 2 is Curie, and the third one is Rutherford. 1 Curie is equals to 3.7 into 10 to the power 10 becquerel, 1 Rutherford is equals to 10 to the power 6 becquerel, and the SI unit of radioactivity is becquerel. What is becquerel, or what is the definition of becquerel? Becquerel corresponds to 1 disintegration per second dps. And uses of radioactivity, there are so many uses of radioactivity. Now I give some uses. Number 1, to estimate the age of minerals and rocks, we use radioactivity. Number 2, radiocarbon dating process is applied for the determination of age of archaeological objects. Age of Earth can be determined by applying radioactivity. Radioactive isotope I-131 is used to test the functioning of thyroid. Radioactive isotope cobalt-60 is used in radiotherapy in the cancer treatment. Plutonium-238 is used as fuel source of pacemaker used by heart patient, and plutonium-238 same is also used as the fuel source of satellite and spacecraft.